Okay, good morning everybody, or I guess afternoon for some of you. My name is Denali Jones. I'm with Retrotec. I'm going to be talking about our DM2 digital pressure gauge. First of all, I'd like to just confirm you guys can hear me. There should be a chat box, or a question box I should say, somewhere on your webinar app. If someone could just type a question or say yes, you can hear me, that'd be great, so I know my mic is working. Okay, good. Someone can hear me. Great. All right, so that's where you type questions. So if you at any point have questions for me, please type them there, and I'll try my best to answer them during this webinar. If I don't get to them, then I believe we should have all your email addresses when you sign up, so I should be able to follow up with you later. Yeah, so you're in listen-only mode, so I can't hear what you're saying. So if you have a question, just please type it there. All right, so just going to start by going over the real basic stuff about the pressure gauge. So DM2, DM stands for digital manometer, and that's what it is. It's a two-channel digital manometer. You've got channel A and channel B. And there are two independent pressure channels. I'll come back to why that's a neat little feature later. But two different sensors, it's essentially two differential pressure gauges combined into one device. So we've got channel A, which is the differential pressure between the red and blue ports, and the yellow and green ports are the differential pressure between them, I should say, is channel B. So if you turn your gauge on, you'll see something that looks somewhat similar to that. You may have a different firmware version or a newer screen, but pushed the wrong button. Anyway, so you've got channel A, which is PRA, that's what we call it, pressure on channel A, and then PRB, which is the pressure on channel B, and a whole bunch of other information which I'll talk about later. So channel A, or PRA, is always going to measure pressure, and it's the pressure difference between the red and blue ports, and that's what we use to measure the house pressure if you're testing a house. So it's the pressure that you're creating in the house with the door fan, or if you're doing a duct test, this would be the pressure inside the ducts that you're measuring with reference to outdoors, or neutral pressure. And channel B is connected to the fan. Now it's just a pressure channel like channel A, but with the mode function, we can actually use this channel B pressure to calculate results like flow and air changes per hour, equivalent leakage area, all kinds of different stuff. So what you're doing is you're converting that raw pressure reading, which you're measuring from the fan, and combined with the flow curves that we've programmed into the gauge, it will then convert that pressure measurement into something more useful, like flow. Real quickly, some common problems that we see. Moving the tubes around, you want to keep these tubes away from moving air or wind. Keep them securely on the floor if you can. Don't have them dangling in front of the fan or anything like that. When you put the red reference tube outside, make sure it's not in the path of the fan flow or in direct wind. Shelter the end of the tube if you can. It'll make your life easier. Another big one is pinched tubes. Anytime a tube is blocked, the gauge can't read the pressure, or it'll read a pressure, but it'll be a huge number. Right, I should actually use the slideshow. Someone's reminding me. So, yeah, if you get it pinched in the door, or around a corner, or someone steps on it, you'll see right away. You get a huge pressure spike. It'll cause big errors in your readings, so try to avoid that. I guess I already covered that. Exposing the tube to wind. that'll also cause big errors. I mean, the gauge is very sensitive. You can, if you have a gauge in front of you, you can actually put a tube in there and just blow gently on the end of the tube and see what kind of pressure readings that you're getting. It'll cause huge errors in your measurements. Also, water in the tube. This is sort of similar to pinching the tube. You've got a blockage, so the pressure can't get through. This is very important if you're in a rainy, wet climate. It doesn't take much to get a drop of water in the end of the tube, and you'll still get a pressure reading. It'll just be the wrong pressure reading. So this is definitely something to watch out for. All you need to do is just shake the end of the tube and then make sure it's clear, and your pressure should go down to 0 once you have the water out of there. That's the end of that basic one. So I'll go into setting up the gauge. So the gauge can be as simple or as complicated as you want it to be. It's got a lot of stuff going on. Most of it you're not going to need to use. We sell this gauge around the world, so a lot of the different units and functions on here you probably don't need, so I'll show you how to turn them off. Someone's asking, does condensation also affect the tube? It only affects the tube if it's fully blocked off. So if there's a tiny little bit of condensation inside the tube, that's okay as long as air can travel freely within the tube. You just want to watch out for a droplet that blocks the entire tube off. So actually I'm going to switch over to the webcam, which, yes, I know is small. I meant to actually get a decent webcam software set up on here, but I'm just using the default webcam software. But hopefully you guys can see this. I'm just going to go through the all the functions on the gauge. So I've got it turned on here. This is just the main screen. So you guys might actually have big numbers on your screen. So I'm going to turn that back on. So the full screen timeout I've set to 3 seconds. So now after 3 seconds it's going to switch to the large display. So that's called the full screen, and it's easy to read from across the room. It shows you your basic PRA, PRB reading and what range you're on. However, if you want to see all the information and you don't like that view, I'll show you how to turn that off. You just push the setup key, number 3, and then use the 2 and the 8. They have the up and down arrows on them to scroll through the setup menu until you get to full screen timeout. And I push enter. Now it's telling me to enter a time. So I'm going to type 0 and then enter again. And now I've turned off the full screen timeout, so I'll always get the small display with all the information on there. I'll come back to those questions later. So I've got it in PRA and PRB mode right now. It's just reading pressure. I'll just start at the top left and go around. You see the battery indicator. That's fairly self-explanatory. That's just how much battery life is left. Or if you've got a baseline pressure captured, that's where it'll show what the baseline is. You can maybe see at the top it says baseline there in small letters. So that's where the baseline would go if it was active. Then the 4 dashes in the middle of the screen, that's where the jog mode or hold mode would show up. I'll go into that a bit later, but that's where it would show up if it was active. The N value, I'm not really going to talk about too much. Basically, if you're testing houses, you should just leave it at 0.65, or really 0.6 is fine too. It doesn't make a big difference. If you'd really like to know more about the N value, I guess let me know and I can email you. But it's the assumed flow exponent that the gauge will use to extrapolate when using at pressure. But as long as it's between 0.6 and 0.65, you're fine, and you don't need to worry about it. The 2S there, is time average. So that's 2-second time averaging. And that can actually be adjusted by pushing the number 5 key. So if you're in a really windy, testing on a windy day, you might want to increase the time averaging. So I'm on 8 seconds now, 10 seconds, 20 seconds, 1 minute. It even goes up to 2-minute time averaging. Somebody's asking if you'd please email PowerPoint presentations. Yes, I can. I guess I'd rather not just send it out to everybody, so please type in the message box or the question box if you would like me to send you the PowerPoint, and I will. Otherwise, I won't bother filling up your inbox with the PowerPoints. Right, so we're on 2-minute time averaging. That's not really what we want. You can also turn it off so you can see how fast these pressures are actually fluctuating. It makes it very hard to read. So we want to have some time averaging. Usually 4 seconds is fine. You know, if it's a windy day, maybe 8 or 10 seconds. 20 seconds is pretty extreme. But that's what the time average setting does. Next, we've got that little off thing there in the corner, the upper right corner. That's the auto zero. And you'll actually notice I'm reading PRA of negative 1.2 right now. And that's actually electrical drift that happens in the sensors because I've got the auto zero turned off. So this is a good lesson here. You should always keep the auto zero on when you're testing. What it does is it actually fires off 2 little solenoid valves which zero the pressure sensors every 8 seconds. So I'm going to push the number 6 key, the auto zero key, and turn that on. And now the gauge is going to zero itself out, and that pressure should drop. So if you leave auto zero off, it will save battery life, but we recommend you always have it on whenever you're doing testing because you want that actually zeroed out, and the sensors will drift over time. It takes maybe 15 to 20 minutes to notice it, but you don't want that happening when you're testing. So I've got auto zero on now, and you can hear, well, you probably can't hear, but the gauge is clicking every 8 seconds. That's the little solenoid valves in there. So that should always be on when you're testing. Then we've got, I'll just go down, we've got PRA. That's pretty straightforward. That's just the pressure difference on channel A. And PRB, it says mode next to it. So right now the mode is just pressure. So PRB, pressure, real simple, just the differential pressure on channel B. Not very useful on its own. So if I push the mode key, so this toggles between the different modes. So now the gauge is trying to convert the PRB reading into a flow. However, it can't do that because I don't have any flow. It's not connected to a fan or anything. So the mode key, the number 1 key, toggles between all the different modes. So you probably don't need most of the modes that we have. So I'm going to show you, well, I'll show you in a minute how to actually disable them. So then going down, this set here, that shows the set point. So if I use a set speed or set pressure function on here, it shows me what I'm setting it to. So let's say I'm doing a house test. I want to set pressure to 50. So that's using the 7 key, set pressure, and then type 50 and enter. And now it tells me PRA equals 50. That's my set point. So I'm trying to reach 50. And then over here you'll notice the speed comes up. This tells me the speed that the fan is going. So it's trying to reach 50. Obviously it's not connected to a fan, so it's going to keep speeding up and never going to get to 50. So we're at 100% speed now, and we're still at 0 pascals. So if I want to cancel that, I just push exit, and that goes away. The range config, that shows us that we're on the C4 range. So we've got 11 different ranges on our fans. It's very important to get that right. The gauge does not know what range the fan is on. So you have to tell the gauge what range your fan is on. And also over here on the right side we have Retrotec 3000. That's the name of the fan or the device. So the gauge also does not know what device it's connected to. So again, you've got to tell it. And if you get this wrong, you can have errors that are easily around 3, 4, 500%. So it's not a small mistake to get this wrong. So you change the range config by pushing the number 2 key, and you can see it toggles through all the different ranges. So and then the device key, the 0 key, changes the different devices. So Retrotec DU200 for duct testing, 1000 or 2000 for house testing, 3000 SR for large building stuff. So it's very important to get those right when you're taking your measurements. All right, so that pretty much covers everything on the screen. Now I'm going to go into the setup menu, which is where you make the gauge simple. So you push setup, and this is where you change all the settings. So you see the 2 and the 8 keys have little up and down arrows on them. I'll zoom out a bit so you can see that. The up arrow and the down arrow, that's how you navigate through any of the menus. So I'm just going to press up, and now I'm on mode setup. I'll zoom back in. So mode setup, that's where you set up all the different modes. So it says enter setup, so you push enter, and now I can enable or disable modes or change the units. So I've got pressure in pascals, flow in CFM. Like if I was in Europe, I could change it to liters per second or cubic meters per hour, or one of the settings is off. And if it's set to off, that means it's not going to show up on the main screen. No matter how many times you push mode, it won't show up. So I'll leave that on CFM. EQLA is equivalent leakage area. So that's the the total size of all your leakage if it were one square hole, or the effective leakage area, which is a little bit different. I'll leave those off. Air changes per hour. So if you want ACH 50, you can get that right on the gauge. Flow per area, so duct testers, you typically do CFM per 100 square foot. I think that's what the IECC says. But we've also got CFM per square foot, or off CFM per 1,000 square foot. So you keep. I'm pressing 4 and 6 are the side-to-side arrows that toggle the units. So I'm just going to go ahead and turn this off. Keep going down. EQLA per area, EFLA per area, whole flow. I mean, a lot of these are not used by most people, or they're used by maybe someone in a different country. So if you don't know what it is and you don't need it, you can just turn it off, and it simplifies the operation of the gauge quite a bit. So I'm just going to leave flow and air changes per hour on, and I've turned everything else off. So now I push exit and exit again to get back out to the main menu. So now if I push mode, you see I toggle between flow, air changes, and pressure, and those are the only things I have enabled. So if that's all I needed, then that's all I'm going to see on the main screen. Now you can do the same thing with devices. So I'll go back into the setup menu, press up one, and now I can enter device setup. So let's say I only have a Retrotec. Well, let's say I do duct testing and house testing. So I've got a Retrotec DU200 and I've got a Retrotec 1000. So if it says yes next to it, that means it's enabled. So I'm going to push over, switch 2000 to no, switch 3000 to no, and 3000 SR to no. Just make sure everything else is set to no. Okay, so I've got just those two devices enabled, so now I'm going to push exit and get back out to the main menu. And now, when I push the device key, I'm only switching between the two devices that I actually own. So if you only own a 1000, you can turn everything else off, and you can never have it set on the wrong device. So that's device setup. I'll just go through the rest of this. Don't know if we have anyone from Europe in here, but you can change it to a European comma separator instead of a decimal. That's how they do things over there. Sig figs, just leave at 3.5. No reason to change that. Building volume, again, if you're in Europe, you can change it to cubic meters instead of cubic feet. Same thing with surface area unit. Power down hour, this is the number of hours the gauge will stay on before it turns itself off, if you just leave it and don't push any buttons. There's the N value, you can just leave that alone. You can display the version info if you want. Battery type rechargeable. So what this setting does is it enables the external DC power jack on the back of the gauge. So if you have a charger, I believe all of our gauges come with chargers, and you have rechargeable batteries, you can plug in that little DC power supply and charge your gauge through that. If you put non-rechargeable batteries in there, make sure to just switch that to not rechargeable, and then it'll disable that external charging socket, so you don't accidentally blow up the batteries in your gauge. Language, English. I'm assuming most of you speak English, so you want to leave it there. You can restore the factory settings if you want, if you really screw things up, and then we're back to full screen timeout and the mode setup. So that's the setup menu. That's where all the changes happen. I see I've got a few questions unanswered. There are small holes in the duct of my duct tester, and I would like to know if this affects the results. Depends on how small the holes are. You can do a field calibration check and see. I don't know if you have a field calibration plate that we made, but that's one way to do it. I can go into that a bit later, but basically you're checking the flow through a hole of a known size and see how much your duct tester is off by. So if they just have little pinholes that you can see light through, it doesn't make much of a difference at all. If you do have like big tears and holes in it, then you probably want to get that fixed. So I would recommend just doing a field calibration check to make sure that your duct tester is still accurate. What is the difference in the 1000 and 2000 device setting? Really nothing much. It's just the primary difference is the speed control is a bit different. So it's going to control a bit smoother if you have it actually set on the right device, but those two fans actually do have the same flow curves. So you're not going to get inaccurate results that way. But the speed control will work a little bit better. How much of this is different than the DG700? Well, I suppose if you're familiar with the DG700, you could tell me better than I could tell you. We try to make it so that it's somewhat intuitive. Our gauge does have more functionality than theirs does. Theirs is a bit simpler, but it'll do most of the same things. I mean, the guts are still the same. It's a 2-channel differential pressure gauge. We both have channel A and channel B. We both have different devices and different ranges. We both have different time average settings. A lot of it's really similar. I believe theirs can't do flow per area or air changes per hour on the gauge. So that's one big difference. What is the difference between range config open and open 22? Open is a duct tester range. That's the open range on our duct testing fan, the DU200. And open 22 is open on a door fan. 22 meaning 22 inches across. That's the diameter of the opening. It's just it's a different name, just so we can keep it straight in our software and whatnot. But it means the most open. Should I be getting a negative reading if I'm doing a duct blast? Well, if you're set up to depressurize, then yes. If you're depressurizing the ducts, then PRA should be negative. PRB, however, should always be positive. If you're getting a negative PRB, then you've got your tubing hooked up backwards, or something else has gone horribly wrong. But if you switch to PRB mode and the fan is running, the reading should always be a positive number. No matter what, if you're pressurizing or depressurizing, it should always be positive for PRB. Okay, we've got another few questions. I previously owned equipment from the M-word company. You can say their name, I don't mind. I own pressure pans and flow meter boxes originally designed for the Minneapolis. Will my DM2 provide reliable readings? Yes. We do have the Minneapolis flow curves in our fan. So I'll go back and show you in the setup menu. You go into device setup, enter. So we've got actually an Infiltech fan as well, the E3. We've got the Minneapolis True Flow grid. We've got their exhaust fan, flow meter, their Model 3 and Model 4 fans. So if you want to use our gauge to measure flow through their fan, you can do that as well. We don't have any way to control their fan automatically, so you can't use the cruise control, is what they call it, or set pressure is what we call it. We're actually working on an adapter right now that will do that, so we'd be able to hook their speed control up to our gauge and use set pressure. But we currently don't have a way to do that. So you'd have to use the manual speed control, but you could still read flow with our gauge. I have the old DM2, and will it do most of what you're teaching today? Yes, depends on how old. I'd need to know the firmware version, but it hasn't changed much in the last, I'd say, 3 years plus, maybe. But it should be able to do most of this stuff, yeah. Can you discuss DM2 calibration? Sure. We recommend the gauges be calibrated every 2 years. There are some standards that actually require annual calibration, which in our opinion is a load of crap, but it is what it is. So if you have to calibrate your gauge every year, then we'll calibrate it every year for you. So we're not the calibration police. It's up to you to be on top of that and send your gauge in. What most people do is the DM2 exchange program, where we essentially send you a new gauge, and you pay for it up front, and then once you get it, we will you put your old gauge in the same box and send it back to us, and then we'll give you a credit. I think the net cost is, I want to say like $400 or $450, somewhere around there. So it's a bit more than just a regular calibration, but you're getting a brand new, a new calibration, latest firmware, brand new warranty. You're essentially getting a full-on new gauge, and you don't have any downtime either. Because if you just send in your gauge for calibration, it can take up to, I think, 3 or 4 weeks sometimes, depending on how busy we are, to calibrate it. I hope that covers calibration. I don't know if you want to know the technical details or anything like that. I guess just ask. Is auto-zeroing different than baselining? Yes, good question. It is quite different. Auto-zeroing is actually correcting for errors in the sensors. So the sensors will start to drift over time. I'm actually not entirely sure what causes it, but I think it might be temperature changes, things like that. Flexing of the actual boards and stuff. But so that the auto zero corrects that. Baseline is when you actually have a real pressure in the building with the fan turned off and covered up. So baselining, when you're testing a house, a lot of standards will require you to cover the fan and take a baseline pressure reading with the fan turned off. So how much pressure is actually in the house, just naturally occurring. So what that does, I'll actually show you. So baseline, if I push the number 4 key, it now says acquiring up here, and it's taking a running average of the pressure on channel A, which is your house pressure. So it says push enter to accept. I'm just going to push on. I'm pushing on the one of the ports back here, the blue port, just to give it a fake pressure. So I'm just going to push enter to accept. So now you see the baseline's active. It has positive 9.31 pascals up here, which is a huge baseline. But as you can see now, it's subtracting. It's showing negative 9.1 on channel A because it's continuously subtracting the baseline pressure from channel A. So if you want to actually hit an induced pressure of 50 pascals, you would correct for baseline this way. So I'm subtracting the baseline. Now when I hit set pressure to 50, I'll actually be inducing a change of 50 pascals instead of an absolute value of 50 pascals. So hopefully that answers baseline. So it's just going to constantly subtract whatever the baseline reading is from PRA, and to clear it, you just push exit, and then it goes away. So that's very different from the auto zero. Do you sell air pans? We do sell pressure pans. I assume that's what you're talking about. Yeah, if you're interested, contact the sales department. What would I use the USB for on the DM2? That's for automatic testing with software. So if you're doing a multi-point test, it's more typically done on larger buildings with multiple fans. Some people do it on residential homes. I think LEED has an apartment test that requires a multi-point test. So we've got software. It's called Fantastic, and you would plug your gauge into the computer, and the software then takes over. So the software will control the gauge, which is then controlling the fan, and you're measuring a bunch of different flows at different pressures, and then it does a whole lot of calculations with them. But the software runs the whole show and then prints out a report. How can you display SLA on the gauge? SLA, I believe, it's something leakage area. I can never remember all the acronyms. I think that's EFLA per area, I want to say. Someone correct me if I'm wrong, but I've got some catching up to do on these questions. Yeah, specific leakage area. So I think it's effective leakage area at 4 pascals divided by the floor area, is it? Anyway, we've got that mode in here. So in the mode setup, you just scroll down to EFLA per area and change that to inches squared per inches squared, which I think is what you're talking about the state of Washington requirement. I believe they use, it's just a unitless number here. So we've got EFLA per area, square inches per square inch, and I think they do it at 4 if I'm not mistaken. Yeah, they've got some conversion formula multiplied by 3.82 or whatever. Yeah, they're extrapolating. It's all combined into that fancy 3.182 or 812 number. But yes, you can do it on here. You just use that mode, EFLA per area, and then you type in the area. So the gauge doesn't know how big the house is. So condition floor area, type or push enter, and then type in the number. So if it's a 2,000 square foot house, type 2,000 and then push enter, and then it'll give you the number right on the gauge. So yes, it can do SLA. Okay, sorry I'm behind on these questions. There are a lot of you in here today. Okay. How much for the calibration? I think, yeah, don't quote me on any of these prices. I think it's like $160 for just the calibration. But yeah, I'd ask the sales guys. Will you be going through the entire process of clean agent retention time testing? No. This is meant more for just a basic getting familiar with the gauge webinar. We do have a whole separate training course for that, which covers the gauge among many other things. I can send you some information about it if you'd like. Can you recycle the gauge sent back? No. So we actually, I should be careful about what I say. We don't send you a brand new gauge for the gauge exchange. We'll send you a refurbished gauge. So we have a stockpile of gauges that have already been sent back. We upgrade all the necessary stuff on there. Change the chipset if we need to, recalibrate it. So it's been used before, but it's basically as new. So we recalibrate the sensors and do all that stuff. So that's what we do with the gauges you send back. We send them out to other people with the gauge exchange program. So you're getting a refurbished, as new gauge, but it's not, it's not actually brand new. I thought baselining was taking a base pressure outside to correct for pressure and wind outside. Yes, that's essentially what you're doing. You're correcting for pressure that occurs on the house without the, not caused by the door fan. So wind or stack effect or anything like that. Do you have a PowerPoint, or will you be doing a webinar on a full house blower door test from start to finish? We've got lots of PowerPoints. I'd be happy to send you some. I don't know if we have any webinars planned for it. Yeah, so I'll follow up with you and see exactly what you're looking for, and I'm sure we have a PowerPoint that would suffice. Is the Q46 the same as the 1000 model? No, Q46 has a 2350 fan, or 2000, Retrotec 2000 is what it's called in the gauge. So it's a different fan, but the gauge is the same, the cloth door panel is the same, just a different fan. But it should perform basically the same. Sorry to ask you to repeat. Open 22 is for duct blaster or blower door. Open 22 is for the 22-inch hole in the big blower door. Open is duct tester. Okay. Does putting the end of the outside reference tube into an empty bottle correct for windy conditions, or will this give you a wrong pressure? Yeah, you can. It would help dampen out the wind. Yeah, people put it in empty bottles, or sometimes they'll put the end of the tube in their DM2 bag and leave their bag open, or in a fan case, or anything to shelter it from the wind. You want to be careful that the opening of the bottle isn't facing directly into the wind, because then the wind will actually go into the bottle and compress the air in there and give you kind of a higher pressure than you want. So make sure the opening of the bottle is not facing directly into the wind. Okay, yeah, so reading more about SLA. Yes, they use SLA in California as well, apparently. Should I put a tube into an empty bottle if it's raining outside to prevent water from getting in the tube? Sure, yeah, that would work. I mean, really anything to prevent water from getting into that tube should work. Are you going to show us how to set up the blower and how to prep the house for the test in this webinar? No, like I said, this webinar is mostly geared towards the gauge. Okay, if we send the gauge to be recalibrated, will you upgrade the firmware as well? Yes, I believe we do, and that's included in the price. So if you don't have the latest firmware, we'll put that on there. We use a bottle in Washington a lot. Cool, yeah, I know quite a few people use that trick. Okay, so I think I'm caught up on questions. I'm going to show you a couple more things. Actually, I've got a fan hooked up in a little simulator tent. I'm just going to connect the gauge here and show you what at pressure can do. Okay, I've got an actual fan connected to it now, and all right. I'm just going to show you set pressure. We'll go to 25 and enter. So I've got it set up to depressurize. So now it's giving me a SLA reading. You can see the percent speed over here that the fan is going. So now if I use the at pressure key, I push at pressure, and you see now it's giving me the results extrapolated to 25. So it's using that N value, the 0.65, to extrapolate your flow to exactly what it would be if you were at 25 pascals. So I'm not exactly at 25, but it's still giving me the number right at 25. I'll just change back to flow. And I'm actually on the wrong range. I think I'm on like C2 over there, yeah. So you can see how big of an error that can cause. So I'm actually on C2. If I, accidentally were to have my gauge set on open, I'm reading 2700 CFM instead of 100. So that's very important to get right. Oops, I went past it. Okay, does a duct blaster give you different information than just hooking up a pressure pan? Yes, a duct blaster will actually tell you quantitatively how much your ducts are leaking, whereas the pressure pan is really, I think it's more just for like balancing, and it gives you kind of rough numbers, but it doesn't it doesn't give you hard data for how much your ducts are leaking. Pressure pan's more just to see how well connected different zones are to outdoors. So there's at pressure, and I just can turn that off by pushing it again. Oh, I should show you the jog and the hold mode. So if I push the number 9 key, now it says jog up here. So if I want to, I can now use this as kind of a manual speed control with the with the 2 and the 8 keys, the up and down arrows. So if I push the up arrow, now you see I'm on PRA equals 30, 35. So I'm jogging the pressure up, the target pressure, or I can jog it back down again. You can do the same thing with set speed. You can use this as kind of a remote control style speed control. So that's the jog mode. And then the next, if I push that same button again, now it says hold. So now it's going to hold this reading and the fan speed until I tell it otherwise. So you can hold the gauge and write down your numbers, and they'll stay in there. Or I push it again and then it turns off. Pressure pan helps diagnose where leakage is located. Yeah, so yeah, by hooking it up to different registers, you can go around and see, how leaky that register is compared to the rest of the system. But the duct tester will actually give you a hard number for your total duct leakage, or duct leakage to outdoors if you've got a door fan as well. So now I'm going to push. Your jog hold only has hold. Yes, you have to have a target pressure or speed for jog to work. So if I turn the fan off and push it, now it just goes to hold and then nothing. So in order to use jog, you've got to have a starting speed or pressure. Do you all have webinars set up for contractors that have purchased your products? No, not really. We do have a lot of free training materials, which we're happy to send out. Or you can email support if you are not sure about how to use it. Yeah, we've got online training as well. Does the software working the gauge make it easy to work the gauge, or does it take away the thinking of using the gauge? The software is kind of a different animal. It's meant for multi-point testing. If you're doing a single point test, it's definitely easier just to use the gauge, and you got all your results you need right there. The software, yes, it does take away all the stuff you need to do on the gauge. The software takes over. But then you've got other stuff that you need to configure and know how to do in the software. So if you're doing multi-point testing, then yeah, use the software, and it makes it easier. But if you're doing single point, I wouldn't recommend it. Right, I didn't show you set speed, but it's fairly straightforward. It's the number 8 key, set speed. You can enter a percentage of the maximum fan speed that you want, and the fan will just go that speed. Not used very much. Set pressure is much easier, but there it is. And then I can turn on jog the fan speed up, use it as kind of a manual speed control, and push exit. All right. Hopefully I didn't miss any questions, but oh, I forgot one thing actually in the setup menu. So in the device setup, if you have a 1000 fan, or any fan, let's just use 1000 as an example. So in addition to turning the device on or off, I can push enter, and actually turn individual ranges on or off. So if you're doing house testing, you probably don't use the L ranges very much or even know that they exist. But those are the 4 little holes in the center of the C8 plate. And they're for like super, super tight, like passive house testing. So if you don't want to scroll through them every time, you can actually turn them off. Let's say I never use C1 anyway. I never have houses that are that tight. So I'm just going to turn those off. So then when I push exit and back out on the main screen, when I push range config, I don't have to go through the L ranges or C1 every single time. I can just have the ranges enabled that I need. So that's another feature to kind of simplify things and disable stuff that that you don't really want. What's an example of multi-point testing? So multi-point testing gives you a more accurate look at what the leakage looks like in the house. Single-point testing, really, you're only measuring it at one point. So you know what the leakage is at 50. That's true, but you don't know what the leakage is at, at 40 or 30 or 10 or 4 or anything else. So a lot of these, energy simulation programs will use, they'll use the normalized leakage area, or something at, where they extrapolate your results down to like 10 or 4 pascals. But you don't really know what your leakage is at those pressures because you've only measured it at one point. So the benefit of doing a multi-point test is you're taking flow readings at a bunch of different pressures, and you can then kind of graph it as a line and then figure out what your leakage would be at any pressure. So for doing energy simulations, it gives you a more accurate look at what the leakage really is in the house. And that's where that N value is. So in the gauge, if you're using at pressure, you're guessing that the N value is 0.65, but you don't really know. 0.65 happens to be a pretty average value that's in most houses, but it could be 0.55, it could be 0.7, and this will affect your results at other pressures when you're extrapolating. So doing a multi-point test allows you to kind of ignore that assumption of an N value. You actually calculate exactly what the N value is, and you can extrapolate more accurately. Confirming at pressure versus CFM versus wrong at pressure. Yeah, okay. So it is possible to use the wrong at pressure. So let's say I'm doing a duct test. I'm just going to switch device. So we'll pretend I'm actually hooked up to a duct tester even though I'm not. So I can go set pressure 25, enter. So I'll let it get to 25 here. So I can push at pressure, and now I'm at 25. So now if I push at pressure again, you see here, oh, I'm at flow too low. Darn. All right, I need to go change the leakage. Well, anyway, I'll just explain it from here. So now you see I'm at pressure 50, which is not what we want. So that's set up actually in this mode setup menu. So you see I've got flow. The at pressure setting is 50. So what that means is when I'm in the flow mode, if I push at pressure once, it goes to whatever I have for the set pressure, which is 25. However, if I push it again, now it goes to whatever's in that settings menu. So you want to be careful when you're using at pressure that you've actually got it set on the right pressure. All right, and you can change in the setup menu what that at pressure setting is. Multi-point testing, do you need more than one fan? No, but you do if you're testing a big building. You can. We've got fans that put out over 8,000 CFM for larger buildings, but in like high-rise commercial building testing, I mean sometimes they'll use 8, 10, 12, even 20 fans or more. And that's all controlled with the software. I mean, you pretty much have to use software at that point because it's just a nightmare trying to manage all those fans individually. Have you heard from other people that 3 air changes have been hard to reach on new houses? I don't know. 3 air changes at 50 is pretty good. Yeah, I don't know. I haven't heard much about that. I'm not too involved with people building new houses, so I can't really answer that. What mode would you use to test isolation rooms or operating rooms in hospitals? I think they have standards for that. I'm not sure what they require. I think it's an air change rate, but I'd have to read the standards. I mean, it should be specified. They'll have some target result that you need to hit. It'd either be an air change rate or a flow per area, something like that. I'd have to look that up though. But it should be specified. If you're doing one of those tests, they should be able to tell you what result they're trying to hit. Yeah. What about a 2-family home? Can it be done with 1 fan for one side? Okay, so like a duplex. Yeah, so for a shared wall that doesn't have, so if you want to test one of those units, you'd have to basically open up the other one that's adjacent to it. So you don't, yeah, so you need a proper return path from the shared wall back to the fan. So you don't want any pressure building up in that adjacent unit, so you'd have to open it up. Yeah, so you could do it with 1 fan, but you'd have to open up the unit that you're not testing. Still new to this, but when is air change rate used and where? So the air change rate is used, let's see, various different energy codes require a certain air change rate. I couldn't tell you off the top of my head, but yeah, a lot of them use ACH 50, which is just the the air change rate at 50 pascals, which you can just do right in the gauge. Change the mode so it says air change, and then enter the volume of the house, and it'll tell you what the air change rate is at 50. All right, so I guess we're wrapping up here, coming up on the end of the hour. Hopefully I got to all your questions. I'm going to look through these and make sure if I missed any, I'll just send you an email. But yeah, thanks for coming, and if you have any other questions, fire them off now. Yeah, thanks, Joe. ACH is required by the 2009 IECC. That's helpful. If a room requires 3 air changes per hour, how do I know how much air to set the fan at? So you're not setting the airflow of the fan. You're setting a pressure in the room. So you set pressure to 50, and then the fan will provide as much flow as it needs to get the room up to 50 pascals, and then the gauge will convert that to an air change rate. And if it's more than 3, then you failed. If it's less than 3, then you pass. And to those of you requesting the PowerPoint, I will send them to you. And I think that about does it. Thanks everybody for coming. Hopefully you learned something, or at least weren't too bored. So yeah, thanks for sticking around.